Scatter plots and trend lines are going to be a very practical application of what you're seeing. You'll actually start to see this a lot in science as you take data from different experiments to see if there's correlations and things like that. So you'll start to hear these words in more than one content area. So scatter plots, they are scattered. It's not going to be exactly linear like what we've seen in the previous lessons, but there is a line associated with it, and that's what we call the trend line. So our target is that we can write the equation of a line of best fit and use that line to make predictions. So a scatter plot, like I said, it's a scatter. It is a graph that relates two different sets of data by displaying them as ordered pairs. So this one is about beach visitors. Notice your x-axis is talking about the average daily temperature. Your y-axis is talking about the number of visitors. So each coordinate on this graph is like a specific day of the year. I don't know which days they represent, that's not the point, but on a certain day of the year, on average that day it's about 82 degrees. When it's 82 degrees, you have about 100 beach goers. But as the temperature goes up, like let's say that it's 94 degrees, it might have 600 visitors or, almost 500 visitors here. So you can see that there is a correlation here. As the temperature increases, you have more people that are attending the beach, which if you think about it is, kind of common sense, but this is a mathematical representation of that. So you heard me use that word correlation. Correlation means that there's some sort of relationship between those two data sets. So there can be different degrees of that correlation. The tighter the dots are in the scatter plot, the stronger the correlation. And then if you have positive or negative slope, that's going to relate to having a positive or negative correlation. So here is a strong positive. They're really close together and it's increasing. Whereas this one down here, they are, increasing, but they're much more spread out. It's not as strong of a correlation. This one is all over the board. Like there's not really anything maybe it could go this way, maybe it could go this way. That shows that there is no correlation. There's no relationship between those two data pieces. Here you see a strong negative. They're close together, kind of a middle of the road, moderate negative, and then a very weak negative. It is decreasing, but since those dots are not close together, it's not a strong correlation at all. So let's practice making a scatter plot. Go ahead and get your graph built. You just need that first quadrant, and in almost all scatter plots, you are just using the first quadrant because in the real life situations that you're going to be representing, it's, for the most part, positives. You might have some negatives if you're dealing with like temperature, but it's not going to be very far into the negatives at all. Make sure that your graph talks, that you have a title. This one is about jeans and the sales of blue jeans. The axes are here, and they are labeled as average price on the x-axis in dollars and the number of jeans that were sold on the y-axis. I don't have a key for this because I don't have different pieces, different types of data. If I were comparing of two different stores, I might do different color dots, but that's not happening here. My intervals, I'm going up every 4 blocks is 25 pairs of jeans, and then every 2 blocks is $5 for those pair of jeans. So let's go ahead and plot these. I'll do them in purple, how about that? So if you pay $21 for a pair of jeans, they sold about 130 pairs. Pretty cheap pair of jeans. And then 130 pairs, so about right there for 21. 130 is going to be actually off the chart just a little bit. So we'll put it about right there. Is it going to draw? Nope. He got mad at me. About right. About right there, wasn't it? Let's draw it back down. Yep. Okay. Erase that one. Alrighty then. Okay. If you charge $28 for a pair of jeans, then you're going to sell, it said you sold 112 pair. So let's think if it's 4, 24, 6, and 6 right there. This is making me mad. Okay, 28, which would be just a little bit shy of that one. move this dot right here. Think it'll let me do that? What do you think? What do you think? Hey, hey. Right there. Okay. Then at 3682, I'm going to do that same thing. I'm going to make my dot, and then I'm going to move the dot. I'm going to go ahead and make those other two dots. Much easier. Ah, they're connected. I can't win. Okay, this dot here. $36 for a pair of jeans. They sold 82 pairs. So 36, and we're going to go up to 82 pair of jeans, which is going to be about right there. And then for $40, they sold fewer jeans. They sold 65 pair of jeans. It's going to be 56. Okay, I think 56, 62, a little bit bigger right there. Okay. So these aren't really falling in a perfect line, and since I only have 4 plots there, it's not a very elaborate scatter plot, but you're probably glad I only made you plot 4 of those. But what do you notice? As the price of the jeans increases, you're selling fewer pair of jeans. So this is going to be a negative correlation, because as your X value increases, your Y values are going down. So whenever you describe that correlation, you kind of want to use this third bullet here. Describe the correlation this way. As blank increases or decreases, whatever it is, blank increases or decreases. So start with your X values. As the average price, as price, what was price doing? Price was increasing. The number sold decreases. People don't want to pay a bunch of money for blue jeans. They like a less expensive pair of blue jeans. Now for the line part of it. A trend line is a line on a scatter plot, and it's drawn near the points that shows the correlation. It's not extremely technical how you draw it. Basically, you take that scatter plot and you put a line in there where you kind of have about the same number of dots above it as you do below it. You'll use a straight edge. Don't eyeball this. Like, don't just kind of take your pencil and, you know, try to draw a straight line, because it's never going to be straight. It's going to look ugly like that purple one I just drew. Take a ruler or edge of a notebook or something. Try to get it situated between the dots as much as possible and draw your line, and then add your arrow where applicable. Now, here's the benefit of a trend line. It helps you to predict. So let's say I'm the basketball coach, and or I'm the basketball player. Wouldn't that be funny? And we're wanting to see how many points I'm going to score based on, in past experience, how many minutes I've played. So I'm pretty awesome. So most of the time I'm in the game longer than 8 minutes. But let's say I was only in the game for 8 minutes. Well, at 8 minutes, based on my trend line, I should be scoring about 6 points. Okay? But let's say I am a rock star, because we all know I am, and I was actually in the game for 40 minutes. If I were to be in the game for 40 minutes, I could predict that I'm going to score 28 points. MVP right here. We just made an interpolation and an extrapolation. Think think interior of a car. That's the inside. Interpolation is when you're estimating a value between two known values. That was this one right here. Because I knew this one, I knew this one, it was between known values. Where extrapolation, think about the exterior of a car, the outside. This is when you are predicting a value that's outside the range of the known values. That was this one right here. Generally, interpolation is going to be a more accurate estimate than, you know, predicting something that I don't have data on the other side of it to compare it with. Don't have to write all this. Don't panic when you see all those words. Whoops. There it is. But I just wanted you to see some application of these scatter plots. So this could be like somebody at the fair or an amusement park or something. To manage ordering supplies more effectively, 3 scatter plots were made to see if there was any correlation, any relationship between daily temperatures and the sale of ice cream, hamburgers, and coffee. So what do you see here? This is a positive correlation on the ice cream graph. And this is in Celsius, but you know, it's getting warmer. You know that. So there's a positive trend here. As one set of the values increases, the other set increases. So You could describe this as the temperature increases, as it gets warmer, you're selling more ice cream, which makes sense. You don't want ice cream when it's really cold outside. You're already shivering. But when it's really hot outside, a big ice cream cone sounds good. Now let's look at cheeseburgers here. Cheeseburgers have a negative trend. As temperature went up, it's getting warmer, they sold fewer cheeseburgers. When I'm really hot, I don't want a greasy cheeseburger. I want something cold, something cooling. Now coffee, on the other hand, there was no correlation there. As the temperature went up, there wasn't really any effect on the sales there. They're going to sell, you know, a decent amount of coffee no matter what, because, I mean, if it's like me, I drink coffee every day of the year, as most coffee drinkers do, regardless of what the temperature is. So next, let's write an equation of a trend line. So if you have that trend line there, and I took the one from the ice cream sales, find 2 points that are actually on the trend line. That's going to make it much more accurate. So 1828, which is right here, is actually on the line, and so is 3074 right there. It's actually on the line. So let's find the slope of those. Change in y over change in x. Change in y over change in x. So the y values of 28 minus 74, and then you have 18 minus 30. So 28 minus 74, it's going into the negatives. That's going to be negative 46. Over 18 minus 30 is again going into the negatives. That is negative 12. And I can reduce that. Since they're both negatives, it's going to be a positive. I can break those down by 2, so that would be 23 over 6. There is our slope. Now we're going to plug those values into slope-intercept form. I'm sorry, not slope-intercept. We're going to plug it into point-slope form. So y minus y of 1. I'm going to change colors. Oh, not crazy colors. Let's do some purple. I'm going to start this up here so I have more room. Y minus the first y value. Let's do these so we have smaller numbers. 28 equals 23 over 6 times x minus the x value of 18. Whew, that's ugly. That reads x minus negative 18. I can't stand it. I'm going to erase it and redo it. There we go, much better. Now we're going to convert that to slope-intercept form. So we're going to have to distribute that 23 over 6. It's going to get ugly. Y minus 28 equals 23 over 6x minus, now I'm going to come over here to my calculator that you can't see off screen. 23 times 18 is 414, big O number, over 6. Okay. Then we're ready to isolate y. We're going to add 28 to both sides. So we have y equals 23 over 6x. And let's see, that 414 over 6. 414 divided by 6 is an even 69. Hey, it actually kind of came out even. So this right here was really 69. 69 plus 28 is 97. I cannot believe that came out as a whole number. Not so bad after all. There it is in slope-intercept form, ladies and gentlemen. Y equals 23 over 6x plus 97. Okay, now let's talk about line of best fit. It's extremely similar to a trend line, but it is a tiny bit different. When we were looking at trend lines, we just kind of, took a straight edge and tried to kind of eyeball where it fell between the points. Line of best fit is going to be the best fit it's exactly the line that goes through that scatter plot. It's a trend line, but it accurately shows the relationship between the two sets of data. I could go through some long, steps of how to do that, but that is why God made scientists, who made engineers, who made a graphing calculator. It's a beautiful thing. A graphing calculator will actually compute this equation for you. You put in your scatter plot data, you push a button, and boom, there it is. And it also gives you an important piece of information called the correlation coefficient. And this could be something that we'll do in class, where we put that into the graphing calculator. We can see how it does this for you. Now here's what you need to know about the correlation coefficient. It shows the strength and the direction of the correlation. So remember when we had one too many. There we go. We had the strong positives, the weak negatives, and we had strong. You've got moderates too, and we were just kind of roundabout, strong, moderate, negative. When you have a correlation coefficient, that tells you exactly how strong or how weak that coefficient is. And that's anywhere from a -1 to a +1. -1 is a definite, extremely strong, or a +1. And then 0.5 is kind of, in the middle, and then you have a very weak one, the closer it is to 0. Another thing I want you to be aware of is causation versus correlation. There could be a relationship between two sets of data, but not necessarily caused by one or the other. Causation is when a change in one quantity causes change in the other quantity. So correlation between quantities doesn't necessarily imply causation. So let's look at this situation. Time spent exercising and calories burned. Does the time I spend exercising, does that affect how many calories I burn? Well, of course it does. If you've ever been on a treadmill, the longer you stay on that treadmill, the more calories you're burning. You can see those calories adding up the longer that you're on that treadmill. So that would be a causation. The time exercising causes those calories to be burned. Here's a different one though. The cost of a family's vacation and the size of their home. Now think about that. Think about somebody that takes very elaborate vacations. They go to Disney World twice a year. They go on a cruise in the summer, and then in fall break they go somewhere. They're always on the go. They typically have a big house, and if you've never been on vacation, it doesn't mean you don't have a big house, but it means you probably have a more moderate or a smaller home. So there is a relationship between these two things. It may not be an extremely strong correlation, but there is something there. However, how much money you spend on your vacation doesn't cause your house to be, enormous. It doesn't cause the other one. So there is a correlation. There is a relationship between those two factors there, how much you spend on vacations and the size of your home, but how much you spend on a vacation doesn't cause your home to grow.